Hey guys, we're going to go ahead and walk through some of these problems real quick. So if we look at problem 2, we have find the length of each side of the triangle determined by the 3 points P1, P2, and P3. What I'm going to do is I'm going to go ahead and just write out. So we got P1 is -1, 6. P2, so point 2 is 5, 4. And then point 3 is 3, -2. Now, if we remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So we got x2 to minus x1 squared minus y1 minus y2 minus y1 squared. So what we're going to do is we're going to plug these values in. So if I want to find the distance between point 1 and point 2, so I want to find the distance of point 1 and point 2. So the distance of point 1 and point 2. What I can do is I'm just going to look at point 1 and point 2. And I'm going to say, okay, I got a square root of, all right, so I'm going to make this x1, x2, or x1, y1, and then I'm going to make this x2, y2. So I'll do, let's see, 5 minus -1 squared plus, and then we've got y, so y2 minus y1, so that'll be y2 is 4 and y1 is 6. Okay. And then what we're going to do is we're going to say, okay, this is going to be 6 squared plus -2 squared, which is the square root of 36 plus 4. Because remember, a negative times a negative is a positive. So the answer is the square root of 40. Now what we need to do is we need to rationalize this. So we look at root 40. We break it down into 4 times 10. And this is 2 and 2. This is 2 and 5. So we're looking for pairs here. There's a pair of 2's. So you can bring these 2's out of the radical, right? So the 2 become 1, bring them out of the radical, and that gives you 2 and then root 2 times 5. Because these didn't have a pair, they are left inside of the radical, right? They're left inside the radical. So you have 2 root 10. So that's your first one. All right. So we can say that the distance between P1 and P2 is 2 root 10. Okay. So the same idea for the next two. So if we're looking at P2, which is 5, 4, and P3, which is 3, -2, we can say, okay, the distance between your x values, so from 5 to 3, I'm going down 2. And the distance between my y values from 4 to -2, I'm going up 6. So this is the distance of my x values, and this is the distance of my y values. So what I can say, remember the other way we did this, is we said that you just do the square root of your x values squared plus your y values squared is the same thing as the total distance, right? So the distance between your x values is -2 squared. The distance between your y values is +6 squared. So we got square root of 4 plus 36, which is root 40, which we literally just did this one. We know this is 2 root 10. Now, once again, I'm just doing it 2 different ways, but you can also use the distance formula, just plugging in x2, x1, and y2, y1. And then last but not least, let's look at P1 and P3. So for P1 and P3, we've got, let's see, 3, -2, that's P3, and -1, 6, that's P1. Let's see, the square root, and I'm going to use the distance formula this time. So using the distance formula, we've got 3 minus -1. That's our x values, the distance between our x values, and -2 minus 6. That's the difference between our y values. That's going to be 4 squared, because 3 negative makes it positive. And then the other one is going to be -8 squared, which is going to give us, let's see, 16 plus -8 squared is 64, which is going to give us the square root of 80. All right, now 80 we can break down. So let's see, 80 breaks down into 8 times 10, which breaks down into 2 times 4, 2 times 5, and 2 times 2. So we're looking for pairs once again. So looking for these pairs, we've got, let's see, 2 and 2, 2 and 2. So we got 2 pairs here. So you could bring both of those out of the radical. But remember, when you have a pair inside the radical, when you bring it out, they become 1. So these 2 become 1 outside the radical. These 2 become 1 outside the radical. And this 5 is left inside the radical. 2 times 2 is 4 root 5. Okay? So now to finish this up, we're going to say, okay, the distance between point 1 and point 2, well, that was root 40, or 2 root 10. The distance between P2 and P3 was also root 40, or 2 root 10. And the distance between P1 and P3, point 1 and P3, was root 80, or 4 root 5. So now what we're going to do is we are going to use this information to determine whether it's isosceles, right, neither, or both. Well, remember, if it's a right triangle, if these 3 create a right triangle, then a squared plus b squared has to be equal to c squared. So let's try it. This is obviously the longest side, and I'm just going to use these values because it's going to make things easier. So root 40 squared plus root 40 squared equals root 80 squared. And we're trying to prove or show that this is true. If it's true, it's right. If it's not true, then it's not right. So since these are the 2 short sides, those are A and B. And this is the longest side, this is the potential hypotenuse side. So let's see. So let's check. Square root of 40 squared, these cancel each other out when you have a square root of a square. So you're left with just 40 plus 40 is equal to 80. Is this a true statement? Yes, because of course 80 is 80, so it is right. Now to check if it's isosceles, isosceles just means that your triangle has 2 of the 2 sides are the same length. So well, obviously A and B are the same length, so it is isosceles as well.